Hello students, so welcome to home-based learning. So for those of you who are on SHN or LA, this is the chance for you to catch up on your work. So in class I went through Practical 3.1 with your peers and I think many of you missed this out. So let's go through Practical 3.1 together. Okay, so first of all, in Practical 3.1, you are given a magnesium ribbon, a pair of tongs, and a Bunsen burner as well as a lighter. Now, I'm not sure how much of this you can actually remember, so I'm going to refresh your memory by first showing you what a magnesium ribbon looks like in the first place, right? So this is a magnesium ribbon, and as you can tell, it is silver in color, and it's also shiny if you look at the ends over here, right? This is a common property for most metals to be shiny, so we are not surprised by this. So in terms of appearance, we can write it down. It is silver in color, and it is also shiny. Right, so this is the appearance of magnesium ribbon. However, in our labs, you realize that the magnesium ribbons have some black stains on them. Now, some of this could be dirt, but it can also be because of oxidation with the surrounding air. Right, but what it really means is that the magnesium is not completely pure. There's some impurities on it, but it does not affect our experiment too much. Alright, so do you recall what happened when we took the magnesium ribbon and we burnt it by putting it under a flame? If you don't, here is another short video on just what I've done with another class. So the thing that's burning right now is the magnesium ribbon held by a pair of tongs. And so you see it burning, right? Now, take note of what you see or what you observe because we'll be using that very soon. Alright, so that will be almost the end of the clip. So what are some observations that you have seen? Well, first of all, you would realize that a bright light has been produced, right? So a bright white light has been emitted or produced. So we do see a bright white light. Now for those who were there, they also could feel the heat coming from it. So we'll include that as well. So heat is given off. Now in the third one, were there any more observations that we saw? Well, actually, after burning the magnesium ribbon, it looked nothing like a magnesium ribbon. In fact, it looked something like this. So it became a white powder. Alright, so the product has a very different appearance after burning. So we saw that a white powdery substance was formed. Okay, these are a few of our observations. But using these observations, which one of them are actually evidences from this demonstration that shows us that a compound has been formed? Well, we've learned in the past that when compounds form, there are a few unique characteristics or a few unique observations that we can make. And one of them is that when heat and light is produced, we know that a compound has been formed. Alright, so the first answer will be knowing or observing that heat and light energy was given out. When heat and light energy is given out, we can tell that a compound has been formed. Now, what's another evidence to show that a compound has been formed? Well, if you recall, the properties of a compound are very different from the elements that make it up. So in this case, magnesium was silver and shiny, but the end product, which was magnesium oxide by the way, is a white powdery substance. And in fact, when I touched the magnesium oxide, it broke extremely easily, right? And it became a white powder, and that is what we mean by brittle. Okay, so it breaks off easily. And so if the end product is so different from the original elements that made it up, this is definitely a sign that a chemical reaction has taken place, and so we have a compound. Alright, so physical properties, or rather the properties, the property of the end product, which is the magnesium oxide, was very different from the elements that made it up. Now, for magnesium oxide, there are two elements that made it up. First one is, of course, your magnesium, and the second one, what do you think that was? Magnesium oxide. Yes, the oxide has to come from oxygen in the air, which reacted with the magnesium itself. So oxygen is also very different from the end product, which was a solid powder, right? And so writing the word equation for this, we actually have magnesium plus oxygen, which gave us magnesium oxide. Alright, so this is our word equation, and this is what is happening. Now, before I move on, let me just add something to the word equation. Now, whenever we heat something up, we have to write it over here. So it's not just magnesium plus oxygen. Putting magnesium out in oxygen will definitely give me magnesium oxide. We had to use a strong Bunsen burner, in fact, to provide heat so that it can change from magnesium and oxygen to magnesium oxide. So when we do that, we have to write it in as well, and above the arrow over here. Alright, so I hope this clears this up, and let's move on to the next question. Now, in the next part, we actually heat sugar, and many of you are so familiar with the heating of sugar. You can always tell me that, the caramel has been made through the burning of sugar and things like that. So here we are actually given just a bit of sugar. We place it in an evaporating dish, and then we use a tripod stand, place the evaporating dish above the tripod stand, and then we use a Bunsen burner to heat it up. Now, can you describe the appearance of sugar crystals? Okay, so they are small crystals, and they are also white crystals, right? White or colorless crystals.